Module 13, Lesson 5, I believe we're on. Yep, Module 13, Lesson 5 covers congruence and transformations. The textbook claims this is going to be a 2-day lesson. There's 15 resources to get through. The first one talks about congruence. It says congruent figures have the same shape and size. This means that corresponding side lengths have the same length and corresponding angles have the same measure. You can show two congruent figures using specific transformations. So the first one would be a translation, and a translation here you can see you're moving a figure from one place to another without turning. A reflection is another type of transformation that shows congruent figures, and an example they have here is the mountain and then the reflection of the mountain and the lake beneath it. And then the last one is going to be a rotation where you take and turn that figure around a fixed point. All three of these transformations give you congruent figures because you did not dilate them. You did not make them larger or smaller. You left them the same exact size. You just changed their relative position. A dilation is also a transformation. It enlarges or reduces a figure by a scale factor. A scale factor greater than 1 gives us an enlargement. A scale factor between 0 and 1 gives us a reduction. When the size is changed, the image and the pre-image are not going to be congruent. If one figure can be mapped onto another figure using translations, reflections, or rotations, then you know the two of them are going to be congruent. So here you can see we got congruent where you take and either rotating it or translating it, sliding it around. Not congruent. These two had a dilation. The sizes are ended up being different. Our inquiry question asks, what happens to a figure when you translate, reflect, or rotate it? And we're going to use a little web sketch here to look at that information. Triangle ABC is shown. We're going to press translate and wait for the triangle to be translated and then figure out, well, what do we actually notice? So here we have triangle ABC, and we're going to translate it, and there she goes. All right, so she's translating. She has moved. What do we notice? Well, we can notice that all the side lengths stayed identical, and we notice that all the angle measurements stayed identical. So the two figures are congruent if it is just a simple translation. Let's see what the next one is going to be. Here we have a triangle ABC. We're going to hit translate again, and we're going to see what this translate is. Well, it's just another simple slide. So once again, in doing this, we're going to see that all that stays the same. If all you're doing is translating it, then you're going to have a congruent figure. Let's move on to the next one. And then the next one after that. Here we got a new type of translation. And this one, boy, they just keep doing the same thing over and over again, don't they? This is getting kind of dull, folks. Here we go. Let's do this one. We have a reflection. So here we're going to reflect it across the y-axis. And when you're reflecting it across the y-axis, we're going to look at our side lengths. The side lengths are all congruent. We're going to look at our angles. The angles, the corresponding angles are going to be congruent as well. That means that once again the entire figure is going to be congruent. It is a reflection of the original figure, but it is still congruent to the original figure with corresponding side lengths being congruent and corresponding angles being congruent. Let's take a look at another one here. For this one, now let's do something different. We've already looked at that one. And we've done reflections already, so we're going to skip that. And here we go. We got to rotate. So we're going to rotate this puppy around. And when you rotate it around, what do you see? Doesn't matter where it ends up at. You're going to have the same angle measurements and the same side lengths. Once again, a rotation, a flip, or a transformation is all going to give you congruent figures to the original figure. Hammering into this a little bit more, we have translations, reflections, and rotations all preserve the shape and size of the figure. We got a few videos to learn about each of these. So, first, modeling a translation.
Model translations. Animated movies are created using frames. Each frame changes slightly from the previous one to create the impression of movement. To make animation frames using index cards, arrange 10 in a pile and trace a parallelogram on the top right of the first card. On the next card, trace the parallelogram slightly down and to the left. Repeat this on 3 or 4 more cards until the parallelogram is at the bottom of the card. Now trace the parallelogram up and to the left on the next few cards. Stack the cards and wrap a rubber band around the left side to form a flip book. Quickly flip through the cards from front to back. Even though the parallelogram appears to move, notice that the sides of the parallelogram are the same length. Use a ruler to measure them. The angles of each of the parallelograms are the same as well. Use a protractor to measure the bottom left angle. It is important to understand that sliding or moving a figure does not change its shape or size.
Well, that was about as exciting as watching paint dry. Let's see what they say about modeling reflections here.
Use tracing paper to model reflections. You can use tracing paper to determine what happens to a figure when you reflect it over a line. Use a straight edge to draw a triangle on tracing paper. Label the vertices A, B, and C. Draw a dotted line near the triangle to serve as the line of reflection. Fold the paper along the dotted line. Use the straight edge to trace the triangle on the other side of the tracing paper. Label the vertices as A', B', and C'. The size of the triangle did not change. Measure side AB to confirm this. A protractor will show that the angle measurements did not change either. Measure angle C to confirm this. The reflection of the object does not change its shape or size.
Well, all right, that covers reflections. Let's keep right on rocking and watch tracing rotations.
Use tracing paper to model rotations. You can use tracing paper to rotate parallelogram WXYZ as shown. Place a piece of tracing paper over the parallelogram and copy it. Trace points A, B, C, and ray AB. Hold the tracing paper down with the pencil eraser on point A. Turn the tracing paper to the right until ray AB passes through point C. The size of the parallelogram did not change. Measure side WX to confirm this. A protractor will show that the angle measurements did not change either. Measure angle Y to confirm this. The rotation of the object does not change its shape or size.
Well, if you don't understand transformations, rotations, and reflections now, I don't think you ever will. When a transformation is applied to a figure and then another transformation is applied to the image, the result is what we know as a composite of transformation or a sequence of transformations. As they showed you in one of those short little videos, that's how they make cartoons. They make a sequence of transformations in order to make the movement you see in a cartoon. On a graph, triangle ABC is reflected across the y-axis to create A prime, B prime, and C prime you see right here. Then that one is going to be rotated counter or clockwise around the origin to make A double prime, B double prime, and C double prime. The symbol with the little double prime thing there, I think quotation mark, is read as double prime and is used to indicate the second transformation. You can show figures are congruent if the second can be obtained from the first by a sequence of rotations, reflections, or translations. We're going to take and highlight that. Since a sequence of translations, reflections, and or rotations does not change the shape or size of a figure, the image and pre-image are going to be congruent. So line segments in the pre-image have the same length as the line segments in the image. Angles in the pre-image have the same measure as angles in the image. Here we have another glorious animation to enjoy.
Triangle DEF and triangle HGI are shown on the coordinate plane. You can determine if the two triangles are congruent by using transformations. First, rotate triangle DEF 90 degrees clockwise about vertex D.
Number 9.
Next, reflect triangle D prime, E prime, F prime across the y-axis. Lastly, translate triangle D double prime, E double prime, F double prime to the left 1 unit and down 6 units so that it maps exactly onto triangle HGI. So, the triangles are congruent because triangle DEF can be mapped onto triangle HGI by using a sequence of a rotation, a reflection, and a translation.
Let's take a look at example number 1. Are the two figures congruent? If so, describe the sequence of transformations that maps triangle ABC onto triangle XYZ. If not, explain why they're not going to be congruent. Moving forward with that, we're going to start off by saying to reflect triangle ABC across the y-axis, select transformation reflect, choose a vertical reflection across the x-axis equals 0. To translate it, so we're going to start off with doing that. So we're going to take and do reflect, and we're going to have it to off the vertical one where x is equal to 0. And so right now you can see where we have taken triangle hold on. Alright, we've taken triangle ABC that was our blue triangle and turned it into triangle A prime, B prime, C prime, and that's going to be this green triangle right here. From here, we just need to translate it up. We need to move it up. So we're going to says to translate triangle A prime, B prime, C prime up 4 units. We're going to click add a translation. So we've added our translation. The next thing we're going to do is we're going to choose a vertical translation with a value of +4. So we're going to do a translation. It's going to be a vertical translation of 4. And now we're getting closer there. Oh, I see. I did 5. We actually need 4. And now you can see that the triangle ABC in its double prime format sits exactly on triangle XYZ. Because of that, we know that they're going to be congruent triangles. So we used a reflection and then a translation to get to where we wanted to be to prove that the two of them sat on top of each other. From here we can say that we had a reflection across what? We reflected across the y-axis followed by a translation of 4 units up made triangle ABC onto triangle XYZ. It checks. That's all there is to that. And I do believe, yep, that's going to be it for that problem. We're going to end this video here. When we come back, it's going to be your turn to work one on extra example number 1. I'll see you in video number 2.